Alright, in this video we're going to be talking about radicals. First, we're going to start off with some terminology. So this entire thing is called a radical, and we can think of them as being the opposite of powers. I'm sure you're very familiar with a square root or even a cubed root. That entire thing is called a radical. Within it, the number you're trying to find the root of, in this case we have it as x, is called the radicand. And the index indicates what root you're trying to take. In this case, we have it as an n. So are you taking the square root, the cubed root, the fourth root, the fifth root, and so on? And usually that number will go in there. So if you're trying to find the fourth root, the number 4 will be where the n is. The only exception is when we're taking a square root. Now normally a 2 should go where the n is, but usually we just leave it blank. So if you ever see something blank where the index is, we're taking the square root. Let's look at some examples. We read it as the square root of 9. Now there's actually an invisible 2 here. This is really the second root, but we do not write that. So you'll always see it blank. And we know that the square root of 2 is 3. Sometimes we'll have something else like a cubed root. So for example, the cubed root of 27 is also 3. So in the first case, 3 times 3 is 9, so the square root of 9 is 3. In the second case, 3 times 3 times 3 is 27. So the cubed root of 27 is 3. Now there's something very interesting when we're dealing with powers, and it's maybe easier to see after we've seen a few examples. If I have 9 to the power of 1/2, if you were to put this in your calculator and just go 9 to the power of 1/2, remember 1/2 is the same as 0.5, so you could also go 9 to the power of 0.5. In your calculator, you would get 3. But we've already seen that the square root of 9, or what number times itself is 9, is also 3. So these two things are the same. 9 to the power of 1/2 is the same as the square root of 9. They give you the exact same answer. Let's look at another example. If I had 8 to the power of 1/3, if you were to do that in your calculator and go 8 to the power of 1/3, you would get 2. Now, there's something else. We can turn this into a radical and get the same answer. So I could actually do the cubed root of 8, and you would get 2. So one thing I want you to notice is instead of writing something as a power, we can write it as a radical. And really all you have to do is the number in the bottom of the fraction for the exponent goes where the index is. So in this case we have an invisible 2, but in this one, 8 to the power of 1/3, the number 3, because it's at the bottom of the fraction for the exponent, is the same as the index in a radical. So what I'm trying to show you is we can write things as radicals, as square roots or cubed roots or fourth roots, but we can also write it as a power that has a fraction as the exponent. So these are interchangeable. So maybe let's try one on your own. If we had something like 35 to the power of 1/4, see if you can write this as an equivalent radical. So in radical form. So the first thing we want to do is we want to do the radical sign. The base of that power goes here. And now we have to figure out what our index is, which is that number in the front of the radical sign. In this case, it's going to be the bottom number of the fraction, which is 4. Let's look at a few more examples. What if I had 20 to the power of 2 over 3. So 20 to the power of 2 over 3. How would we write this as a radical? Well, first of all, we want to do our radical sign. Our base is 20, so it becomes the radicand. And really the tough part is kind of figuring out what we do with this fraction. We said the bottom of that fraction, the denominator, is going to be the index. So the 3 goes right over here. But what happens with this 2? We haven't seen this before. Before it was something like 1/3. Now we have 2/3. Well, in this case, that's an exponent that is going to stay with the 20. So the bottom of the fraction, the 3, becomes the index number. But that top part of the fraction, the numerator, stays with that 20. Let's try another example. 17 to the power of 4/5. So this is a power or exponential form. We want to turn this into an equivalent radical. So right away, I'm going to have my radical sign. I know the base in that power is going to be the radicand. Right away, the first thing I like to do is I like to take the bottom of that fraction in the exponent put it as the index. And then I can't forget about that 4, the numerator in my exponent. It's going to stay as an exponent with my 17. So it becomes the 5th root of 17 to the power of 4. So we have 55 to the power of 3/5. I want you to pause the video and turn that into a radical. So in this case, I'm writing the radical sign. The base of my power goes right here. The bottom of my fraction in the exponent, the 5, becomes the index. And the numerator just stays as an exponent. So it becomes the 5th root of 55 to the power of 3. This is just another way of writing things. What if we have a situation where we have a decimal number? So we have 100 to the power of 0.5. And what if I was asked to put this as a radical? Well, in this case, we're actually kind of lucky because we're dealing with a very nice decimal. What I can do is I can turn this into a fraction, and it's going to make things a little bit easier for me. So instead of to the power of 0.5, I'm going to have 100 to the power of 1/2. Because 0.5 as a fraction is just 1/2. And if you do that in your calculator, 1 divided by 2, you get 0.5. Now we're not done. I want to turn this into a radical, but the fraction form is just going to make things a little bit easier for me. So I have my radical sign. I'm going to put in 100 right away. The bottom of my fraction for the exponent is the index, remember, which is 2. But usually we don't write the 2, so it's invisible 2. Just like often when we have a number, we'll have an invisible 1 as an exponent. We do not write it. Now here's the question. For the numerator as a 1, where does it go? Well, we know it's going to be right here with the 100, but we know any number always has an exponent to the power of 1, so we do not usually write this 1. So 100 to the power of 0.5 is just the square root of 100. Let's look at some more questions. What if I had something like this, the 4th root of 4 to the power of 3, and I were to ask you, can you put this into a power with a fraction as an exponent? Well, the first thing I would do is I would notice the radicand is 4, so it's going to be the base of my power. And I know this is going to be a fraction. That 3, that right now is an exponent, is going to be the numerator in my fraction for the exponent. And the index, the other 4, is going to be the denominator. So it becomes 4 to the power of 3 over 4. What about this? I have the square root of 5 to the power of 3. Let's turn this into a power. Well, my radicand becomes my base, the 5. I know that 3 is going to be the numerator in my exponent. And now the question becomes, what is my denominator? Because I don't see a number for the index. But remember, there's always an invisible 2 here. It becomes 5 to the power of 3 over 2. What if I had something like this and I asked you to turn it into a radical? Well, this might require a few steps. The first thing I notice is I have multiple exponents, and I can probably simplify this using exponent law. Well, I know if I have two exponents and they're separated by that bracket, I can multiply those exponents together to simplify things. Now, one of these exponents is a fraction, so then it's easier if I actually think of both of these as fractions. So I'm going to multiply those two together. So my base of x is going to stay the same. And when I'm multiplying the fractions, I multiply across the top, multiply across the bottom. So 2 times 2 is 4. And then 1 times 3 is 3. So this is just simplifying this so it's a single power. I haven't turned it into a radical yet, but sometimes we have to do an extra step just to set something up. So how do I turn this into a radical? Well, I know where that base of x is going to go. It doesn't matter that it's a variable. I know a variable just represents a number, so you can treat it just as a number. The bottom of my exponent, the denominator, is a 3, so I know it's going to be the index. And that exponent of 4 for the numerator is going to stay. That numerator of 4 is going to stay as an exponent right there. So this simplifies to the cubed root of x to the power of 4.